first thing we're going to do is, you guys can hear me, right?
Yes.
Okay. So work. So it's work is basically said to be done when force, sorry, an object moves in the moves a displacement in the direction of force applied, which basically means that work is force times displacement. But what you guys need to remember is that they must be parallel. Now obviously this is a scalar quantity and the SI units for work are joules. Okay. So then right. So then basically in case one, let's look at this and we'll try to understand what's happening. So you apply a force on this box. It moves through a displacement. So obviously work is done because it moves, right? But in this case where around the Earth, the satellite is moving in a circular orbit. I'm sorry, I could not make circular orbit more than this. So the force of attraction is towards the Earth and the satellite is moving like this. Do you guys think work is being done due to gravity? Yes. What do you guys say? Why? Because they are, yeah, they're not exactly in the same direction, right? So zero work. It's good. Similarly here, if there's a slope question and you want to know what is the work done, so there are two ways of this. One way is that you simply, like it goes from here till here, so work done would be W times H, because this force and this distance is like parallel. All right, everyone, do you guys understand what I'm saying? The other important thing is that if, let's suppose this displacement was given, then what you're going to do is you're going to make components of it. So you're going to say one component is down, one is like this is theta, so this component will be W sine of theta, and that would mean that work is going to be W sine theta, and the parallel distance is this, so you're going to do S. Is it clear? Any questions, please? Okay. The next. So then we have, I hope you guys have written this. Let me know if you guys have any questions here. Okay, next. So next we have energy, and energy is capacity to do work, the SI units of all sort of energies are joules, and why work is also joules, because they're the same thing. Without work you can't gain energy, and without energy you can't do work. Anyway, so it is also a scalar quantity, and it has multiple formulas depending on which kind of energy we're looking at. So the list of energies, I've tried to list most of them, and one of those is potential energy. And potential energy, hello.
हाँ यार जो तू मुझे बच्चे भेज रहा है ना
Mm-hmm.
उनके ना अपेरेंटली डेमो नहीं हो पा रहे
Why?
अब हाँ आयशा ने ना कल बकर को कॉल आयशा के उसने बहुत थॉरली सारा एक एक बच्चे का बताया कि इसके साथ ये मसला है ये मसला
Mm-hmm.
है
Mm-hmm.
यानी डेमो ही नहीं हो पा रहे एक नया तो दूसरी बात है अब यू कॉल बकर या यू आज बकर ठीक है जरा इस पर दिमाग लगाओ कि हम कैसे ये बच्चों को दिलवा सकते हैं
Chalo, see, I'll talk to him, then I'll talk to you. Okay.
दूसरा ये है
Hmm.
कि भी 3 श्रीलंकन बच्चे थे ये मैंने टोटल दोबारा लिंक भेजा उस टाइम पे उन तीनों ने मेरे साथ क्लास में डन करके गए
Uh-huh.
क्या हमें टाइम कल मैंने लिंक भेजा सफरा को ठीक उसने कहा कि बच्चे को वीकेंड पे मिलेंगे
Okay.
अब मैंने उनके साथ मंडे ट्यूसडे वेडनेसडे का टाइम लगातार रखा है 9:30 PM के
Okay.
और उसके सफरा के वो टाइम ठीक
Okay. Tell Bakar. Tell Bakar I don't know anything about it. ठीक है? बाकी मैं देख लेता हूँ. Okay. Bye. All right. Then potential energy. You have three kinds of potential energies. You have elastic potential, which is basically stored energy due to change in shape. So when you change shape of something, energy stores to make sure that it comes back. And then gravitational potential energy is work done against gravitational force. All right. Do not write against gravity, because gravity is not a force, it's just a term that we use. I don't know why. Anyway, electric potential is work done in moving electric charge. So that's something. All right. Then kinetic energy is due to motion. Anything moving has kinetic energy. Chemical energy stored energy in chemical reactions, whether it's happening like in body or like in other reactions that contains chemical energy. Anyway, then thermal energy is the heat energy, and light energy is energy carried by photons. Then you have sound, that is the energy that is transferred by longitudinal waves. And then we have nuclear energy, energy released when unstable nuclei break down. Then internal energy is sum of potential and kinetic energies within a system, like that. All right. If you guys have any questions now, please ask me. Thank you. Sultanatin, Maham, and Javeria, everything is clear. And
Yes.
Zahan and Khatija. Okay. Where's the other Khatija? I forgot about her. That's not fair. Hello. All right. Now, please write this down so we can go forward then. Next. next is. Hello Yaya, how are you? Yaya, did you forget about the class? Okay. Okay, going to the next then. So, for example, in this sort of question, it says two boxes x and y have the same mass. Box x is lifted vertically through a height h by a force of magnitude f. The box y is pulled along the slope by a force of the same magnitude to reach the same height as shown. Now, what it says is that which statement is correct? Both boxes gain the same amount of gravitational potential energy. And the same amount of work is done by the two forces. Is that true? I don't think so. Because the thing is, in this, yeah, sort of. This basically does work like F, if this was S, it would have basically worked like this, and this is F time H, right? So that's different. Both boxes gain the same amount of gravitational potential energy, but more work is done by the force acting on the box Y than the force acting on the box X. Okay. Now, because they reach at the same height, so one cannot gain more or less. So obviously gains less or more, these two would be absolutely wrong. Do you guys understand what I'm saying?
Yes, sir.
But technically, depending on what kind of question is this, if the force, they say the force of the same force, like for example, this was like 100 newtons, all right, just to test this in the question, although it seems like B is correct, but let's check, right? So, and this was maybe like 30 degrees, I don't know. So, and the height was like 10. I'm just assuming, keeping the value same. So here it would be like 100 times 10 would be 1000 joules. But here it would be, because, you have to make, you have to find this. There was angle theta here. So we would use sine theta equals to perpendicular over base, perpendicular hypotenuse. So hypotenuse will be 10 divided by sine of 30. And obviously, that would come out to be close, like less than that. Let's check anyway, divide by sine 30. So that's 20, right? So this would be 20 to reach the same height. And then if you do it, so one would do more, one would do less. So it means that obviously they will have different work done, but because of the force direction, the distance moved, but both gain the same potential because they have the same height. So it should be B. Is it clear, everyone?
Yeah.
Okay, very nice. Then you got law of conservation of energy. Law of conservation of energy says that energy can neither be created nor destroyed. That's your favorite one. It can only change from one form to another. Perfect. Now, for this one, this question, I love this question, it's so good. Basically, it says that there is a bead that rolls from point B and goes to point Q, and it has a speed here as well. So it says the track loops around this forms a vertical circle of diameter 40, and at point Q the beads have the speed this. Air resistance, friction are negligible, which means that overall the height it has fallen is this much. Do you guys understand this? Overall, I'm saying, which means that the change in the energy initially was basically gravitational potential energy, and it has gone to kinetic energy, and it has also, like, this much change has gone to kinetic energy. Otherwise, if you want to take this h, then you'd say the other has gone to gravitational potential energy again. Do you guys understand this? Naturally, we need this. So we would use mgh. The kinetic energy at that point will be half mv squared, and then mgh again. The mass is not given, so you don't have to worry about it, because mass, the bead is same, so mass will just cancel out in each term, and it's going to be gh equals to half v squared plus gh. In questions like these, if mass is not given, do not worry about it. Just write the whole equation, you'll find your way out. Anyway, so then what happens is, that's going to be 9.81, that's going to be h. Half, the velocity at that point was 1.4 whole square, 9.81, and the height it gained later on was 40 centimeter, which is 0.4 meters. I'm going to use the calculator for this, and 0.5 times 1.4 square, and then plus 9.81 times 0.4. So that's basically 4.9, and I'm going to divide it by 9.81. So h should be 0.50 meters, which is this answer. Is it clear? Right. So then, if you have any questions, please let me know. Maha, Yaya, Khatija, Sultanat, Zahan. Okay. Fair enough.
Yes, sir.
Cool. So this one, well, this is an interesting question I found. I'm gonna do this, and the other one you're gonna do. So in this question, it says when the jumper makes the jump, his initial gravitational potential energy is converted into kinetic energy and into elastic potential energy. It says at which part jump all types of energies are non-zero. So first of all, it says on the platform. At the platform where she's staying, so she is at a height. So currently we're gonna look at that gravitational potential energy goes into kinetic energy, and then obviously as the cord will begin to stretch, kinetic energy will go into like kinetic energy plus gravitational energy will go into elastic potential energy, right? So here right now these two energies are completely zero. This is there, so this could not be the answer because we need all non-zero values. On way down, before the cord has started to extend, if the cord has not started to extend, it means it does not have elastic potential energy right now. So it means in that case you have this one, but not this one, so that's not the answer. On the way down, as he decelerates, now when he starts to decelerate, which means the kinetic energy is going into gravitational potential energy, and there would be gravitational potential energy as well. Kinetic goes to elastic potential, and there would be gravitational potential as well because he might be like somewhere above the ground, which means that this is the answer. At the bottom of the jump, when he's stationary, at the bottom there will be little bit of gravitational potential energy left, and elastic potential energy will be left, but kinetic will be zero, which we do not want. That's why this is also wrong. Okay, let me know if you have a question now. Okay. Okay, now I'm going to go forward, and we're going to talk about, yeah, oh, this is pretty easy. You're going to do this on your own. But I'm going to do the next one. So it says a stone of mass m falls from the rest, top of the cliff, height h into c below. Just before hitting the c, stone has speed v. What is the average force of air resistance? Now, when the stone is falling, so obviously its weight is down, air resistance will be up. And the thing is that the gravitational potential energy is basically changing into kinetic energy, plus it is doing work against friction or drag, right? So we want to find the average force. So gravitational potential energy will be mgh, kinetic energy will be half mv square, and the work would be force times the height it has fallen. Do you guys understand that? Right. So then I'm gonna basically move this on the other side, so it's going to be mgh minus half mv square, and this is going to be f times h. Okay, then obviously you need to take mass, because they have taken mass common in all terms. We're going to take mass common, so we're going to get gh minus uh, half v square, and then we're going to divide h from the other side, so we get f. What do you guys think is the answer then? Seems like the answer is this one, because if you divide h,
Could you please repeat it?
repeat from here, from here.
Yes, sir.
Okay, so what I've done is, if you look at it, I know that if it's falling from cliff to the sea, then I know it has fallen this much height. You agree?
Yes.
At this point, the object will have gravitational potential energy, which is basically going to go into kinetic energy, but also it is going to do work against friction. Do you understand?
Yes.
So it means that this gravitational potential energy will be equal to the kinetic energy, that's the useful work, and then work against the friction right here. Okay, gravitational potential energy is given by mgh, kinetic energy is half mv squared, and work against drag would be force times the height it has fallen. Understood?
Yes.
Then what I did, I took this term on this side, so it will be mgh minus half mv squared. That would be equal to the work done against friction. Get it?
Yes.
Then I divided this h right here, and I got this expression. So next what I'm doing is I'm dividing h, so it is mgh, sorry, it's m outside, but gh divided by h minus half v squared h, right? So this h and h cancels, so it's going to be g minus v squared over 2h, and that should be equal to force, and that's c. Understood?
Yes.
Okay, you can write this down, because yeah, why not? Okay, very interesting. And I'm gonna go to the next. Okay, next. So now we need to basically learn how to derive these two, and derivations might come, so let's do that. So first of all, for gravitational potential energy, we got to learn that work done is force times displacement. So when something falls from here, so force is the weight, all right, so that goes into basically gravitational potential energy. So we can say the force is the weight, which is w, and the displacement is h. Since w is given by mg, so gravitational potential energy becomes mgh. So this is the most, like, this is the simplest derivation you can find. It's very simple. But kinetic energy is not that simple. We're gonna have to use a diagram for that. So suppose that we're looking at speed in meters per second and time here. So suppose an object starts from speed 0 and goes all the way to speed v in time t. Okay, so we need to basically understand that the displacement it has moved is actually half times v times t. You guys agree? Okay, in fact, to remove t we can do it in a simpler way. We can say 2as equals to v square minus u square, where s is the displacement, initial velocity is 0, final velocity is v, acceleration is, let's say, a, and time is t. Doesn't really matter there. Okay, so then what you're going to do is you will have to basically, yeah, so what I'm then going to do is I'm going to write this as, because work is basically force times displacement, and I'm going to write this as force as mass times acceleration times displacement. Call this my first equation. Okay, according to this then, so it's going to be 2as equals to v square minus 0 square. So I'm going to get 2as equals to v square, and that's my second equation. So what I'm going to do is then, if you look at this, I can write this equation as as equal to v square over 2. Can I do that, please? And if I put this equation, like you see, as is right here, as is also right here. If I put this equation right back there, so work done can be written as m times v square over 2, right? So then work done will be, half will come out, mv square, and that's basically equal to kinetic energy. Do you guys understand this? Any questions, please let me know. Oh no, sorry about that. Please have a look and let me know if you still think you need help with this. Okay, so keeping that in mind then, so we're gonna go towards the next thing, and we're gonna talk about this question. Okay, so this is a very simple question, not a very easy in fact. We just need to understand that it says that rope is attached and the tension rope is 100 and the rope is at 30 degrees, and it says how much work is done when it's pulled 5 meters along the surface. We want to go 5 meters, but the issue with this is that the force and the displacement are not in the same direction, so we got to find the parallel one. We're going to make two components. We're going to make one component like this, one component like this, and you might see it becomes 100 cosine of 30, and then you got to find work done, which is 100 cosine of 30. Always find the distance and the force in the same direction, or maybe opposite, doesn't really matter. They need to be parallel in any case. So we're going to do 100 cosine 30. Uh-oh, what happened? 30, and we're going to multiply this by 5, so we got about 433, which is C, as two significant figures. Okay, then in the next one says kinetic energy of the mass moving speed equation shown. Which equation is not used in the derivation of this equation? Do you guys, which equation was not used? Yes, let me know. We just did it. I think you guys can answer this. Yes, Hatija and Wajiha and Javeria. Yeah. Which of these equations we never used? That's not fair. Go back and see. Did we use F equals to ma? Right here. Very bad. Did we use 2s equals v square minus u square? Right here. Did we use work done in force into displacement? Right here. Is there any other equation we used? So, no. Which means that the answer would be, yes, the answer would be
B.
B. Very good. So unless you do not do this derivation on yourself, you're gonna forget about it. So please make sure you do it. All right. So this is by far the latest question. It's very, very annoying as well. So what I'm gonna do is we're gonna look at this. It says initially 4 blocks of initially 4 identical blocks of mass m thickness are spread on the table. All right. So then it says that the acceleration of free fall is g. How much work is done on the blocks when stacking them on top of one in each other? Okay, so this is the question. Just look at it and see what you expect. Okay, so now this question is a very, very tricky one. So initially this one will stay here. Do you guys agree? You don't need to move it, right? Because you need to stack the next box on top of it, so you wouldn't have to move it. Do you guys understand what I'm saying? So you need to move 1, 2 and 3 boxes. So if I put this box here, so obviously I need to go this height above the reference line. So what I'm going to do is I'm going to say moving the box 3, I need to do mgh. Okay, when the box is stacked here, which means it is here, so this is 3, it means now the height is double. Now it is 2h. So the next box, when we stack it right here, it means that to stack box 2, I need to do m, g and double the height, so it's going to be 2h. You guys agree? Okay, I've stacked 2 as well. And now when I stack 3, I have to go this much height, which is 1, 2, 3, 3h. Okay, so when I stack this, which is 1, then for 1, I got to basically do work mg times 3h. Now I did work on 3 of them, not 4 of them, because the 4th was already there. So which means total work done. Okay, this seems easy, but it's not. Okay, the real time. So it's going to be mgh plus 2 mgh plus 3 mgh. So I think it's going to be 6 mgh. Where is the answer? B. All right, is it clear? Okay. Now this question, like in the examiner report as well, many students got it wrong, because what they did was they took this height S4 mgh. Okay, and then they thought, okay, this is 4h and that's how the work is done, but that's not true. You have to check each one after another, like that. All right, then these questions are, these are very simple questions. I'm going to just give you this as homework. If you find them difficult, you can always ask me in the next class. Okay. This is also very, very easy, so you can do this as well. Simple mathematics, simple question. Yeah, this is very easy as well. Please do it as homework. I put so many questions I put that I don't know. Yeah, very easy as well. Please do it as homework. Let me find a difficult one. Okay, I'm going to do this one. So in this question, first you need to define acceleration. You can just write rate of change of velocity. Then what you're going to do is you say that there is a person, a toboggan, is at rest at A, and then he moves down, and there are different slopes to the horizontal, as you can see. And then it says that the man has a combined mass 95, and the man starts from rest at A and a constant acceleration from A to B. The man takes 19 seconds to reach and speed is 36. So calculate the acceleration. Fine. So as you can see, that this is a classic question of SUVAT. And I need to close it, wait. Okay, so displacement is now given, the initial velocity is 0, final it says is 36, acceleration is A, and the time it takes is, where's the time? I read somewhere 19 seconds. Okay, so we're going to use V equals to U plus AT. The final velocity is 36 equals 0 plus A times T is 19. So it's going to be, I think, 36 divided by 19, and the acceleration ought to be 1.9 meters per second square. So that's pretty simple. Then say show that the distance moved from A to B is 340 meters. Okay, fair enough. Now you can use the SUVAT again if you want to, and this time you can use 2AS equals to V square minus U square, or you can simply use the other one, which is, I think that would be easier, UT plus half AT square. So we want to find this will be 0 because the initial velocity was 0, this was 1.9, and the time here was 19 square. So that would mean that it's going to be 0.5 times 1.9 times 19 whole square, and it comes out to be 343, which is basically to two significant figures. It is this one shown. Alright, so this usually the questions paper 2 are mixed because energy, I have seen very few questions of energy that stand alone of energy work power. Usually they're mixed with forces or kinematics, stuff like that, so you have to do this. Anyway, then it says for a man and toboggan moving A to B, calculate the change in kinetic energy. Now you see the final velocity it reached was 36, so I'm going to use half mv square. I will say 95 was the mass and the speed was 36 whole square. So I'm going to find this simply, 0.5 times 95 times 36 whole square. This is going to be 62,000 joules. Okay, that says change in potential energy. Now the issue is that we know for the fact that this distance is 340 meters, and the potential energy would depend on the height that we don't know. So you can use a little bit of trigonometry. You can say sine theta is equal to perpendicular, which is the height, over hypotenuse this. So the height will be 340 times sine of 40 degrees. Okay, so that would mean we're going to use mgh. So mass was 95, this was 9.81 multiplied by 340 sine of 40 degrees. And now you got to go and just calculate it. 95 times 9.81 times 340 sine of 40. So that's going to be somewhat like 204,000 joules. Okay, so then if you look at the answers, they're quite different. And if the change, because you should understand that if it's losing gravitational potential energy, it should be going to kinetic. But in the next question, it will ask the same question about the frictional force. So you should understand that the gravitational potential energy loss has gained into kinetic energy, plus work is done by friction. Okay, so it means that the work done against friction forces will be 204,000 minus 62,000. So this will give you the change in energy that is basically lost to the surroundings in form of heat or whatever, and this is 142,000, and then you need to use force into displacement. Okay, now the tricky part in this one is because we want to find the force and we got to divide the displacement, so I'm gonna ask you, should I divide it by 340 sine 40 or just 340? Who's going to tell me this? 340. The reason why we need to divide with this value is because the friction force will be against this. So we're doing work against this distance. So obviously distance has to be parallel. So we're going to divide by 340, and that should be 420 newtons should be the friction force. Okay. Then says a parachute opens on the toboggan as it passes point B. There is a constant deceleration of this from B to C. Calculate the friction force that produces this deceleration between B and C. Okay. Now parachute opens, so it means at this point you have a speed of 36 meters per second, and you want to find the frictional force that the toboggan experiences that produces this deceleration. Now we need to understand few things here. First of all, if you see, this object will be here and its weight is going to be acting downwards, so naturally there will be two components of weight is going to be down, and then one component is going to be here, right? And this angle theta is going to be 20 degrees. So we can say the weight is trying to go down, so this will be W sine theta in the forward. So weight is taking down, and there has to be friction force that is acting against it. Okay, so that would mean that the resultant force F will be equal to the weight sine theta minus the friction. Who agrees with this? Okay, so weight will be 95 times 9.81 times sine of 20 minus the friction force equals to, now we're going to put it equals to ma, because this whole is the resultant force. Okay, so instead of ma we can write 95 times acceleration is given as 3. So this is a tricky question here because it instantly switched from kinematics and then into energy and now into forces. So your brain should work that way, that you can, within this chapter you have to make sure that you take all possibilities in account, because obviously they are there to trick you. 318.7 minus F equals to 95 minus 95 multiplied by 3285. So friction will be equal to 318.7 minus 285. So almost like 320 minus 285, and that's going to be 35 newtons. Okay, have a look at this and let me know if you have a question, please. Okay, Sultanat and Maham, everything is clear. Juwairiya, Khatija and Yaya and Zahan, any doubts left? Okay, now the next thing we're going to do is okay, so then we're going to look at power. Power is very simple. Power is just work done. Okay, let me write work done per unit time, or it's also energy over time. So power SI units are watts, which is capital W, or you can just write joules per second as well if you want to. Okay. Now power is again a scalar quantity. There is a small derivation that is also involved, so I'm just going to do that. So you guys should understand that since power is work done over time, and work done is force times displacement over time, so you see displacement over time is velocity, so you can write it as force times velocity as well. So here then power will have three formulas really: work done over time, energy over time, force times velocity, and some electrical formulas as well that we're going to do later on. It's all right. So you can write this down. This is a small derivation that you might need. All right. So keeping that in mind, we're just looking at this question where it says that a car of mass 400 traveling at straight horizontal road in constant speed, the output power of the car is 30 kilowatts. The car travels up the slope at 2 horizontal, maintaining the same constant speed. What is the output power now? Fine. So when something moves in a constant speed, it means whatever force it is putting here, there is a resistance force that is equal, so they're like balanced, right? So we want to maintain the same power, but now you need to understand that it was doing work against the friction forces only. Okay, right now if it maintains the same speed, now it also needs to do work against the weight of the car, because the component of the weight, one will be like this, one will be like this, right? This is 12 degrees, so this will be basically W sine theta, and obviously the friction. Okay, so we're gonna look at that in that sense. So let's do this. So we already know that this is the amount of power that it was spending in order to overcome friction. We just need to know how much power is needed to overcome the gravitational force. So the weight of the car is 1400 times 9.81, and then sine of 12. So that would be the weight multiplied by sine of, oh, we've done this. So this would be the force, and the velocity of the vehicle was 25. So I'm going to multiply 25, and then I'm going to get the power that I need to overcome the weight. So according to my calculator, then it's 1400 plus 9.81. Sorry, multiply. I have to do. Sorry, 9.81 multiplied by sine of 12, and then multiplied by 25. Sine of? Oh, oh no, sorry, my bad. I thought it was 12. Okay, I'm gonna do this. Okay, so this then becomes 11,982, which is basically essentially 11, like 12 kilowatt, right? Where there's 12,000. So 12,000 for taking it against gravity, plus 30 kilowatt in doing work against friction. So the total is going to be 42. So that has to be C. Is it clear?
So why did you multiply force with velocity for this particular?
Because power formula is force times velocity. We have to do that. Do you understand?
Yes, sir, but we did multiply 12 kilowatt with 25.
Shouldn't we multiply 12 kilowatt with 25? What do you mean by that? We have to find, Sultanate, we have to find this force. We have to find this first to know how much power is needed to overcome this against this velocity if you want to maintain this velocity. Do you understand this? Is it clear now? Should I go forward?
Sir, could you please do this again?
Can I do it again?
Yes, sir.
Okay. So what I'm doing is, so imagine this. First of all, you should understand that when maintaining constant speed, right? Constant speed, it means the force that the engine provides has to be the same as the force of friction. Do you agree?
Yes.
That would mean that the power that is needed to overcome friction has to be 30 kilowatt at this speed. Agreed? Now the
Yes.
speed has not changed, so this will not change as well. But when the slope was there, so the weight was acting down, one component will act like this, perpendicular to the slope, one parallel to the slope. This is 2 degrees. You understand? And if this is the weight. So this is the speed where it is going against. So we're not going to take this one because work is done in the direction of force and the displacement moves. So this force is W sine of theta. Get it?
Yes.
Now, if you look at this, W itself is 1400 times 9.81, and when you do sine of 2, you would get this force. Now, power is force times velocity, so you got to multiply this whole thing with 25. This whole thing multiplied with 25. Do you understand?
Yes.
The force I got here, this force, is basically the power needed to overcome gravitational force, right? So that would be 12 kilowatt. So total engine power that is now needed is this one and this one, so that would be 42. Understood? Like that.
Yes.
Fair enough. Now the next question is very easy. You guys got to do it yourself. And this is very similar as well. This question is exactly the same that we have just done now. So you will be able to do it hopefully. If you don't, let me know. This is also the same thing. Very easy question. In fact, the first part of the previous question that I did is the same thing as this one. Now, this is the question I want to talk about. So the power required to move an object through a medium at constant speed depends on the speed v and the resistive force F acting on the object. The resistive force F also depends on speed v. So which row shows a possible relationship between v, resistive force and power? Okay. So power, it says the power required to move object medium through constant speed depends on speed and resistive force. So power will be force times velocity. What do you guys say? Right? Okay, guys. And here, if you look at this one, it says the resistive force also depends on V. So let's call this KV. Okay. So definitely the resistive force is dependent on V. So the answers would be somewhat dependent. I don't know what that is. But if I check the first one, it says the resistive force is proportional to V square. That is not exactly, we don't know this. It just says it is a possible relationship. If this was a possible relationship, which is true to what I've thought, but then says power stays constant. So power would not stay constant. If the speed increases, power cannot stay constant because power itself is related to V. That would mean that A is an incorrect answer. Do you guys understand what I just said?
Yes.
Now, in relation to that, if I want to, put the real relationship between power and velocity, I have to put this constant and V here. So it means power would be like kV and times V. So power will be kV squared. Now, why this question is difficult? You see, if force is related to V, then power should be related to V square. Do you get my point? That's how it works, in my opinion. Now, if force was related to V raised to power 2, power would be related to power 3, because every time you put V square into this equation, you get another higher power of velocity.
I would take this.
Sorry? Okay. Okay, I'm gonna explain it again. Imagine this, right? So I'm gonna write a very important rule here. We're gonna say in physics, we can only compare two things and keep third constant. All right, is that clear? So this is the rule I'm following right now.
Yes.
So my initial idea is that force times velocity is equal to power, right? Now in this equation, the issue is this and this, they both changes, and because they both change, we cannot compare power with velocity. Do you understand? So we have to replace this somehow. Is it clear? Now it says force is also somehow related to velocity. I don't know how, but it is related. It could be square, cube, power raised to power 4, 5, whatever. Is it clear? Now if I put this back into this equation, what do I get? Power will be equal to kv square. Do you agree? Now we can relate them. Okay. Now in the first section, if I put force proportional to just v, power should be proportional to v square. You agree?
Yes.
But it says constant, so that's wrong. Understood? If I put v, power should be equal to v square, which is not the answer here, which means b is wrong as well. Do you understand? Now if I put force equals to kv square back into this equation, so it's going to be power equals to kv cube, but it's not there, so this has to be wrong. If I put kv square back into f equals to like this one, so it should be kv square times v, so it's going to be kv cube, which is the correct relationship, so it has to be t. Understood? Very difficult, right? So it's kind of a difficult question, but obviously you have to follow up with the rule that whenever you're comparing two quantities in physics, all the other quantities in that particular equation must be kept constant. And because force was not constant, so we had to replace it. Is it clear?
Yes.
Okay, so the next thing, obviously, homework, very easy question as well. Homework. This is a tough question, but I'm going to do a similar question, then you'll be able to do this homework as well. So I put so many questions. Why did I do that to you? Okay. So we're going to do efficiency, and then the question I put star on the homework, we're going to do it forward, so you'll learn how to do it. So efficiency is basically denoted by eta, and efficiency is basically useful output over total input. It could be energy, it could be power. So you can find percentage efficiency as well. Useful output over total input times 100%. The other formula you guys need to remember is that the total input has to be equal to useful output plus wasted. All right, is it clear? One thing that I want to tell you, and that's just a note for you people, that you should write as well. The note is that amongst all of this, amongst everything, electric heater is 100% efficient. Nothing in the world is 100% efficient except for electric heater, because in any other kind of heating system or anything, whether it's heating system or not, heat is a energy that is lost to the surroundings, right? But electric heater is sort of a heater which we need heat as a useful resource. So that's why even if it's losing to the surroundings, obviously we are gaining useful output. So it's 100% efficient, and they might also ask you this question. Anyway, so moving on. So in this one it says the pump of water pumping system is 2 kilowatt of electrical power when raising water. The pumping system lifts 16 kg of water per second. Now when you get this kind of question, sometimes they would write this as kg per second like this. So you should always understand that. Okay, so input power that we have is 2 kilowatt, and water is being raised. The mass is 16 kg. The time is 1 second. Okay. So vertical height. The height is like 7 meters. What is the efficiency? So output, because it's going into gravitational potential energy, so we're going to use mgh 16.9.81 times 7, and then power output will be divided by 1 second, obviously. So then 16 times 9.81 times 7 divided by 1 would be about 1100 watt, which is 1.1 kilowatts. So then what you're going to do is just divide efficiency 1.1, we need percentage, divided by 2, multiplied by 100%. I think it should be around 55%. So that should be the answer. All right, is it clear? Very subtle and easy. So you're gonna do this one. This is the very similar question. Also do this one. If you don't do this, because it's the same thing, as you can see, just the clue from here, it says 200 kg per second. It means you got to take mass as 200 kg and time as 1 second. It means nothing else. Do not worry about something like this, okay? And it uses the same principle that we've used just now. Okay, where's the question I intended to do initially? Let me see. I don't know where that question is. Chalo, never mind. All right, I'll do that question myself then. So the last thing you're going to do is the work done of with relationship of work done of and pressure with respect to gas. So suppose this is a piston which had this much of a volume initially. Okay, so let's call this V1. And when the piston was pushed inside, like here, then you got this much volume. So this is volume final. So we can say the change in volume that occurred was final minus initial, or initial minus final, whatever you want to do, it doesn't really matter. And to do work, we had to apply a force, and the displacement it moved for this. So work done is force times the displacement x, right, like this. And obviously, if you notice here, pressure is given by force over area. So what I'm going to do is I'm going to replace force with pressure times area. So this is my first equation and this is my second equation. If I put it right here, then what I'm going to get is I'm going to get work done equals to pressure times area times change in x. If you see this, if you realize what this is, you might see that change in volume is also area times change in x. So I can put it here. So work done is pressure times change in volume, and that is the equation I need. Okay, now this equation that I have just derived can only be used for constant pressure. If the pressure is not constant, then this equation is not used. So you should always remember this point. All right, please write this down and let me know if you have a question here. Okay. All right, guys, everything is clear. Should I move forward? We just have 10 minutes left. Yeah. Sultanat, Yaya, Maham, Zahan, Khadija, Irfan. Okay. So now, so for example, in this question, it says you need to do this and how much work is done. Can you guys tell me which answer is correct?
A.
Yeah, A. So easy, right? Very nice. And the rest of them is very simple, as you can see. Even in this question, like which I'm going to give you as homework, you might see that this one has like they have given you like length to find the change in length, whatever. But the thing is, you got to find the change in volume, which I just told you how to, and you have the pressure right here, and then use the pressure into change in volume to find that. Anyway, same question here. Do this on your own, very similar. And then I've given you a lot of practice questions, like a lot of them. So I think that would be enough for you to do over the weekend. Make sure you submit this, but I'm gonna do the last question that that is required, that I put as homework, but I shouldn't have, because I did not put a similar question of that. Okay, this one. So in this one, it says that an escalator in an underground station has 250 people standing on it. So there's an escalator like this. Let's draw this like this. And there are 250 people on this. And then it says, and it's moving with a velocity of 4.3. So it is moving with a velocity of 4.3 meters per second. And average mass of person is 78, fair enough. And the angle of accelerator to the horizontal is 40 degrees, okay? And then what is the minimum power to lift these people up? So that's the question. Now see this. So the force that is required to, to work on it is the one that is because of the weight component. So this is the weight of the person, all the people. And then obviously one is going to be perpendicular to the slope, one is going to be parallel to the slope. So it means this one is going to be W sine of 40 degrees, okay? Now each person is 78 kgs multiplied by 9.81 would give you the mass, and there are 250 people. So that would be the total weight of everybody. And then sine of 40, that's multiplied. This would be W and what we need to do, like, okay, let me do step by step. So this would be W sine theta, and that is the force we need. So that's gonna be 78 times 9.81 times 250 and times sine of 40. Okay, so this is the total force that basically is needed to overcome like this. Okay, then power is force times velocity, because this force and this velocity are in the same direction, really. So 122,962.06 times, we're going to multiply 4.3 with this, and I'm gonna get 528736.8, which is basically 5.3 times 10 raised to the power 1, 2, 3, 4, 5 watts. So I don't know where the answer is, but I think the answer has to be 530 kilowatt. All right, is it clear, you guys?
Yes.
So obviously forces are involved. Please make sure that when you're doing this, just be careful, that's all. All right, so the chapter ends here. I'm gonna post these notes as well today, because a lot of people forgot about the class. That's not good. Okay, so and then please complete this by Monday, so that you guys have you're done with at least this one. Now we are only left with, I think, deformation waves, which are going to be done in 1 and 1 classes, and probably by the end of the March we're going to finish it, hopefully before end of the last week. I think we'll be able to finish. Then I'm going to probably give you like a break of 1 or 2 days, and then we're going to start the past papers. So where you at? The past paper booklet is going to be like, I'll send you the booklet myself, and if you have one already, you don't need to print it. Okay, wait, where did we start? 99. Okay, all right, so see you people next time. I'm putting it and creating the assignment as well.